We'll get started with the presentation. The person with the new solar isn't here, so we'll go straight into the presenter. So Jônatas, can you please ad lib and introduce yourself to the group before you get into the presentation? You're based out of McGill, I believe it is.
Yeah, exactly. Thank you, Doug. First of all, it's a pleasure for me. Thank you very much for this opportunity to speak a little bit about electric vehicles, electrification. I'm really happy to be sharing with you what I've been doing in the last, I don't know, 5 years maybe. And I'm also eager for the discussion that might arise later from this discussion. And as I am a postdoc at McGill, and I'm working in the IMaTS lab, with a laboratory here at McGill that develops some solutions for sustainable transportation, electrification, and road safety. And yeah, I believe that's a really big pleasure for me. Can I continue, or there's something else? I'm not hearing anybody. I don't know if you're hearing me well. I think so, right? Uh, so yeah, maybe I'm gonna continue. I'm not seeing you really well as well on the audience, but yeah. In any case, so today, as I said before, the idea is to talk a little bit about electrification and
Sorry for
transportation. Yes.
interrupting. I'm a little
No.
hard of hearing. Some people are finding it okay, but can you speak
Okay.
into the mic just a little bit more?
I'm using my earbuds, so I don't know if I can speak loudly. Maybe it's better
Yes.
or not. Yeah, it's better. Okay, so I'm gonna speak a little bit louder. Hopefully the neighbors are not gonna complain. But anyway, it's a pleasure to be here. Can I continue? It's okay. Are you hearing me well? It's fine. Uh, I believe so. I don't know. Can you thumbs up? Yeah, it's good.
Please continue.
Okay, great. So yeah, as I said, just a little bit of my background, right? I'm now a postdoc at McGill, but my story is quite long, and I've been in different places. I'm Brazilian originally, and I did my bachelor in electrical engineering. I have a double degree in Brazil and also in Munich, and the Technical University of Munich in Germany. And then after this, I moved to Portugal, and then I acquired my master's and also my PhD. And now currently I am at McGill as a postdoc, and my research and topics of interest are transportation, optimization, electric vehicles, energy, sustainability. So all those related matters that you are also discussing in this group is something that I'm really interested in. And to start this, I just want to tell you a story that happened with me um, some time ago. So as I said, I did a double degree in Germany, and when I was living there, I was an intern for a company that probably you know, that's BMW. Um, and ironically, I was working with internal combustion engines at that time, and the team of the internal combustion engine. And one day, one of my colleagues, we kind of having lunch together, right? And he came, approached me, and he asked me if I knew Tesla, if I ever heard about Tesla. And then I said, yes, of course, Tesla. It's a really famous scientist. He did brilliant things, right? Amazing scientist and etc. And then the guy started to laugh at me, and he said, I'm not talking about this Tesla. I'm talking about a new car manufacturer that's starting the operation on the US, right? And this was around 80 years ago, more or less. And it's funny because although the story is funny by itself, but it's funny because today, if you ask someone in the street what Tesla is, probably it's gonna say that it's a car manufacturer and it's gonna forget about the scientist. So this is because we are really facing a change on paradigm, right? Maybe 8 years, 10 years ago, electric vehicles were kind of sci-fi, or I don't know, as technology that we didn't know if it's going to be something in the future, but today we can definitely say that the electrification is coming and is coming to stay, right? So it's just a matter of the pace that this transition is gonna reach, but definitely it's gonna happen, right? And it's already happening. And this is happening mainly because of three pillars. So the first one, we are seeking for more sustainable transportation, more efficient transportation means, and also carbon free. Of course, the carbonization of different economic sectors is mandatory, and we are really seeking for those um, carbon-free technologies. And just to give you a bit of panorama, and probably you are aware of that, but just highlighting some aspects. Um, Here I collected some news just to see what is the landscape in general. And later I'm going to also focus a little bit on transit, so you can also see what's the panorama mainly in China and also in Europe, but I want to give this highlight. So when we look to the market, right? So this is 2022, which we're already a pandemic. We are under pandemic at that time, but even so, the EV market reached almost for $100 billion at that year, and every year we are selling and selling and more electric vehicles. So this is not a news anymore. Um, China is really leading this transition. And one thing that's interesting is that they removed the subsidies in China, but even so, they still buying electric vehicles. So it also shows that there was a change on the cultural behavior of the customers in China. They are really buying EVs not only because they are subsidized anymore, but also because they understand that this technology is better, right? When we look to what are the key players, we can see here that there are different players, but there are two main giants that are disputing the market right now, with obvious Tesla, as I said before, but BYD in terms of sales still the biggest one in the world, and then BMW is lagging behind. So, but we can see that there is a big gap between the two first companies that are leading the market and the third one. And then another thing that's interesting to highlight is that at least in Europe, right? So in North America, in the US mainly, we're seeing kind of a change in the political landscape. But in Europe, we are really having a focus on the decarbonization of transportation. And we have was from legislation in the EU to ban any kind of new petrol and diesel cars from 2035. So this is a really changing paradigm, because it's not only about transitioning, but also banning the all other technologies that are not carbon free. And this is going to change a lot on the landscape, right? Because it's also going to be mandatory to have any kind of EV or other carbon-free or zero-emission vehicles in Europe by 2035. And if we put in perspective, 2035 is around the corner, right? But I also want to highlight a little bit about on electric buses and transit, because this is my main area of research where I've been developing most of my studies. So just to give you an idea on where the market is, how is it evolving? So, I mean, if you're aware, China is leading by far. When we look to the market share in the world, China holds around 85 to 90% of the electric bus fleet in the world. So they really almost have a monopoly there. And I'd always like to bring this example of Shenzhen, which is the home of BYD. So they have a fleet of 16,000 electric buses there, and 22,000 taxis there that are all electric. So it's a massive fleet of electric vehicles there. And also just having another look on BYD, they are delivering those electric buses all over the world, and they already reached more than 70 thousand in the entire world, which is amazing to think. Also, an interesting aspect is that in Europe we already seeing a shift on the market share. So in the first quarter of 2023, in the first time, the sales of electric vehicles and hybrid vehicles were higher than the diesel ones. So, and when we sum the sales of electric and hybrid, they are more than double the sales of diesel. So this also points to this massive change on paradigm and also this transition that's really face-based on Europe. Even in Canada, we also have some funding for this transition, but maybe we can even discuss in more detail. But we are seeing that we got some traction in the last years, but maybe in the future it's kind of uncertain how it's going to evolve. But even so, there were some budget to support the purchase of at least 5,000 electric buses here in Canada. So also the distraction to the electrification of transit. This is just also to highlight how fast is being the adoption. So here is the annual sales of electric buses, excluding China. And we can kind of see that's a trend that's quite rising exponentially, right? Which also shows this increase on the adoption rates. And there are other companies that are also electrifying. So it's not only transit, but last mile also are being involved on this transition, right? So UPS, Amazon, FedEx, and I always like to highlight the case of Amazon, where they're aiming to have more than 100,000 cargo EV vans by 2030, which is also a massive number of vehicles. I had the chance to talk with someone from Amazon, and they said that the electrification process is working really well, and actually they are really happy with the EVs because in terms of operation, they are not having any issue to operate, which also points to a good future in vision. And then just to give you another idea, this is how is the global share of EVs in different sectors and segments, right? Long haul, personal or light duty, electric buses, and also two-wheelers. So two-wheelers, we have a lot of vehicles there that are electrified, mainly because in China and other Asian countries, they use a lot of electric two-wheelers, scooters, and etc. But this is kind of the perspectives that we have right now. And just also to highlight the needs that we have to decarbonize, to meet the decarbonation standards that we are aiming for. So we need to cut emissions by 25% into 2030. We need to have 3/4 of EVs in the streets by 2050. And then probably which one is the most challenging aspect of the decarbonization of transportation is to decarbonize aviation and shipping in the future. I mean, I'm mentioning this, but this is out of the scope of this talk today. But we can also talk about this later if you're interested. But in terms of challenges, those are the biggest challenge that we are facing today. So how are we going to decarbonize aviation and shipping? And talking about challenges, right? So there is a lot of challenges when we're talking about transit and electrification buses mainly. And I want to highlight a little bit about those challenges that most of the transit operators are facing. And I always like to separate those challenges into two different categories. So the first one is the transition. So when I don't have any kind of EVs or electric buses, how do I plan my fleet? What are the main points that I need to look at if I want to go electric? And once I got this fleet, how I can better operate it. So those are basically the two main challenges that we face, the operators face. So I just want to break down first the transition and later the operation, just to give some examples on what we are observing right now. So when we are talking about this transition, right, and the planning phase, the first big issue is the fleet size. So how many vehicles do we need to buy? What's the battery capacity? What's the chemistry of my batteries? So, and how I can also have an optimal size of the fleet, because as you imagine, the capital costs are really high. So how we can have a fleet that can meet my operation standards, but at the same point, not have a fleet that's bigger than should it be. So how we can optimize that. Then the charging infrastructure is also a big challenge here. First, because we need to know exactly which type of chargers we need to use, what the charging power, and also which charging strategy we're going to use to charge our vehicles. Not mentioning that also we need to prepare the depot for receiving the amount of power that we're going to need to use to charge those fleets. So there is also connection with the utility. So all of those aspects so really painful during the planning phase. And the last part is the total capital cost, because as I mentioned before, EVs is still more costly than diesel when the upfront costs. So reducing the as much as the operators as much they can, this upfront cost is kind of mandatory to make most of those electrification planning project viable, right? So also having tools that help them to have a better look on how the total capital cost is going to be is really, really important. This is a more or less in short words, what are the challenges on when they're in the planning phase. And then we move to the operation phase. Well, so in the operational phase, we also have a lot of challenges. And I want to highlight four main challenges here that are the main ones, right? The first one is the grid integration. So um, the grid integration is how we're going to charge those vehicles, how we're going to control the charging vents, um, and how our depot is going to be prepared for receiving the power amount. So this exactly how this interaction with the grid is going to work. The second part is the energy market. So the grid is more about the technical assets, the assets that I need to have to make it work. And the energy market level is how we're gonna navigate in a market that's completely different from the market for diesel, for instance. So in the energy market level, we have different tariffs. We have power peak that we need to deal with. We can have demand side management strategies to reduce the bill, the energy bill. So there's a lot of aspects that need to be considered when we are navigating an energy market level. The third one is the stochastic operation. So any kind of transit system is operates under uncertainty, right? So we don't know exactly how long a trip's going to take. Maybe the traffic's going to be different every day. We're going to have weather conditions that also impacts the operation. So all of this, the stochastic operations also a problem for diesel vehicles. But when we are dealing with EVs and electric buses mainly, this also impacts a lot on the energy consumption of the vehicles. So sometimes those unpredictable behaviors can impact a lot on the energy consumption. So knowing how to deal with stochastic events of with uncertainty can also help on have a better estimation of energy consumption and also a better operation of the vehicles. The last part is the battery degradation. Although those vehicles today, we are proving more and more that battery degradation is not a big issue. Um, by a bunch of factors. First one, normally those batteries are under warranty, so operators doesn't care much about the degradation. And also because we're seeing that um, the battery doesn't degrade as fast as we expected before. Increasing the lifespan of the battery is still an interesting aspect for those operators. So if we can increase a little bit, maybe in 2 3 years, that my battery lifespan is also gonna make the value that I put on my fleet even better, right? So also dealing with battery degradation and having means to reduce the battery degradation can be an interesting aspect for those operators. So just to give you then some examples of those challenges that I'm mentioning. First one, I want to present spoke about the Shenzhen bus fleet. So as I said before, they have 16,000 electric buses operating in the city. And imagine that we're going to charge all the vehicles at the same time using, I don't know, slow chargers, kind of 50 kilowatt per charger. So if we do this at one shot, we're going to need 800 megawatt, right? Which a lot of power. And just to put on perspective, that's power similar to one of the biggest dams that we have here in Quebec, which is Laforge one. So imagine that we're going to need to build one entire dam just to power electric bus fleet. So this is quite not possible, right? So therefore, it's also necessary to have the control of the charging events. But just to give you an idea how big this problem can be when we escalate the number of vehicles. The energy market level is also, as I said before, is a new entity that those operators need to understand how to navigate because, as I said, there are different prices during the day. Even those fleets can be used to energy arbitrage. So buying energy when the energy is cheaper, right, and selling energy back to the grid when the prices are higher. Even though I don't believe that V2G could be used in the short term, but anyway, those possibilities when we're dealing with the market are possible, right? So having that in mind is also interesting. Um, and as I said, stochastic operation. So this is a big issue when we're dealing with energy consumption and also the power demand. So um, knowing better or having tools that can predict a little bit on the behavior of the fleet and based on this uncertainty, also have estimations on energy consumption can be really good to make all the operation of the electric bus systems more reliable. And last but not least, as I said, the battery degradation is also an interesting topic to increase the fleet lifespan and also in terms of potentially using those vehicles to V2G assets. We could also need to have an assessment of the battery degradation to guarantee that the energy that's going to be sold to the grid or the price that the grid is paying for the energy is higher than the degradation that we are imposing on the batteries. So it's also an important topic to be addressed. Yeah. Anyway, this is all. I give you a lot of ideas on the panoramas, right? So what are the challenges, what are the broader landscape where we are moving to. So this was kind of more high level introduction of the topic. And now I'm going to enter a little bit more on exactly what I'm doing in my research, how we're trying to tackle those problems, what are the tools that we developed. So maybe here the talk is going to be a little bit more nerdy, okay? But hopefully you're going to enjoy it too. And later I'm going to be really happy to answer any questions that you have about this. But now I'm going to be a little bit more technical and presenting what we have been done in the laboratory and also in terms of development of tools to make this transition better and also to improve the operation of those electric bus systems. So, as I said, we have all those challenges, and in my perspective, I believe that the computational intelligence play a big role on making those transportation systems more reliable and better used in the city environments. And I always like to present this framework because this is basically what we developed during my PhD and also during the postdoc now that I'm continuing my research. So basically, we try to build a framework that can control the charging events and improve the operation. And by that, we have developed different modules. So we have developed mainly three different modules. So the first one is our optimization module that considers the interactions between the fleet, which I'm calling here the public transportation operator, and the market operator. So we consider all the interactions between the fleet and the energy system. And when I'm saying these interactions is the charging events, the schedule, the number of vehicles, the number of chargers, the price of the energy, the battery chemistry. So we get all of those information and we optimize the operation of the fleet. Basically, what we're trying to do is to minimize the operational costs related to the charging events. But as I said, we also have some challenges on that. So therefore, we have built two modules that are coupled to this optimization framework. The first one is an energy consumption model. So we build a simulation approach with a robust model to have an assessment of how the energy consumption of the vehicles are going to behave under stochastic operation. And also we have built in laboratory a battery degradation model to estimate the battery degradation of the vehicles due to charging events. And because of that, to reduce also the degradation by optimizing the charging events in a more healthier way, let's say like this. And then as the final outcome, we can have a smart bus operation strategy using all those tools that we developed in this framework. And later I'm going to present two real case studies that we have done in Portugal using this platform. So first I want to go to the optimization framework. I'm not going to enter much detail in mathematically speaking, but I just want to give you an idea how does it work. So uh, the core is here is to minimize the operational costs of a bus fleet. And to do that, we consider different aspects of this operation. So the charging scheduling. So what are the needs and constraints regarding the charging scheduling? We also consider energy trading. So in our platform, it's possible, or we can active a V2G module if the operator wants to. We also have a battery management module where we try to minimize the battery degradation. We also need to consider the route assignment of the fleet. So we have an assessment of the routes, and with this we can try to assign the vehicles to each route to minimize also the energy consumption of the vehicles. And we also have an assessment of different cost components on the operational costs, energy costs, and charging costs. So basically, those are all the features that are encapsulated inside of our optimization model. And then breaking down a little bit more in terms of inputs, what we need to make this work is we have to need information about our fleet, so the number of vehicles, the capacity of the vehicles, what's the chemistry, information about the routes. So how many routes do we have? What's the time schedule of the routes, and etc. Information about the charge infrastructure. So how many chargers do we have? What are limitations of the grid capacity, and also grid characteristics, which also needed. And in terms of the optimization, which is the second part where the magic happens, we consider different constraints, grid and tariff constraint, routes and schedule, energy and power. And then we also have, as I said before, the modules. So a module for the energy consumption and certainty, and one module to the battery degradation. And with all of this information, we can have some interesting outputs that we can build a smart charging routine for the fleet operators, assessment of the battery degradation due to the charging event, and also we can assign the fleet to the routes based on all the calculations that we do in this platform. Then moving forward, I just want to present really quickly the simulation tool that we developed, and also the battery degradation model that we developed. So the simulation approach, basically what we did was an agent-based approach. So an agent-based approach is basically we have different entities in a simulated environment, and those entities, they work as a kind of a standalone agent, right? And they have different tasks in the simulated environment. And in this case, all those agents, they kind of having their transit tasks, right? And with this, we can um, extract the information of those agents, which in this case are the buses, and we extract this information and we can get a speed profile of those buses. Then we have built, based on the speed profile, energy consumption model using Python, it's a programming language, right? And then we can feed our optimizer with this estimation of the energy consumption based on the simulation that we have done. And with this, we can have a more accurate energy consumption and also optimization of the vehicles based on a more accurate energy consumption behavior that comes from the simulation that we have built. Um, our simulation approach was developed inside of the IMSAM software environment, and we have developed different calibration parameters for the fleet, and we consider the dwell time, speed limit, bus size, average speed, and also the schedule of the fleet. And for this module, we also consider different scenarios using different strategies, operation strategies. Business as usual, where the vehicles and the buses, they share the same lanes. A signal priority strategy where the buses, they can always have priority on this signs. So it's always kind of green for them. So this also impacts on the energy consumption. And a third scenario where the vehicles have dedicated lanes plus signal priority, so they are kind of always running, is almost a BRT style, the operation. So the idea here is also to have how this would impact on the energy consumption. Um, to stimulate or to have um, uh, assessment of the energy consumption, we have used a physics dynamics model, which this one, probably you are remembering your physics classes when you're seeing this figure, but basically what we built this using the speed profiles to feed these physics models. And then we have get some results from this. And actually what's interesting just to highlight here is that the results showed that using those techniques with the signal priority and dedicated lanes, the vehicles consume less energy and they operate in a more optimal way, although they do not recover much energy from the braking, regenerative braking process. But was an interesting study that we have done. And then moving to the third model that we developed, which is the semi-empirical battery degradation model. Here, we try to assess what would be the degradation of the battery based on two different levels. So in our optimization model, we estimate the degradation costs of the vehicles based on a throughput model with ampere hour throughput model. So this modeling approach basically considers that until a battery reaches the end of life, it's going to cycle amount of energy. So every battery has an estimated um, energy amount to be cycled into the end of life. And then with this, we know that for each cycle of each charging event, we are degrading the battery X amount, right? We can have this insight, how much percentage we are degrading our battery every time we charge the battery. So this is the first level that we have used, and this is what we're using in our optimization model. But then we need to have an idea on how we're going to estimate this amount of energy that is going to be cycling to the end of life, right? So to do that, we have a second level assessment in our models we developed a aging mechanism in the laboratory. So we identified different aging mechanisms. So to do that, basically, we have used what we call a battery semi-empirical degradation model. So we went to the lab and we cycled different battery cells, lithium-ion cells, and with using kind of the driving profile of electric buses. And with that, we could estimate and accelerate the degradation of those cells. And here you can have an example of the chemistries that we use, LFP and NMC, and also the rules that we use to discharge. But basically, at the end of the day, what we did is we approximated a curve that's a physical curve into the degradation degradation behavior that we observed in the laboratory. And then I think this figure is better to exemplify. So the points are what we observed in the lab, and the curves are the approximation or the data fitting that we use to approximate the degradation that we observed in the laboratory. And with this, we could extrapolate what would be the energy throughput of the battery into the end of life based on the models that we developed. And what we did also was considering different temperatures, different uh, driving behaviors, also to have a more accurate estimation of different battery um, um, capacities and estimation over time. And here you can see what are the final results, how we could extrapolate the energy throughput over time. Then I just want to finalize presenting some strategies some case studies that we run in the real world. So this is Coimbra, which is a city in Portugal where I did my PhD, and we developed a lot of pilot projects there, and just want to share with you some results that we got. So if you're planning to go to Portugal, I really recommend you to go to Coimbra. It's a beautiful city, as you can see. But the first case study that I want to show you, it's regarding a small fleet they have there with 11 electric buses with a small battery capacity, 88 kilowatt hour. The charging infrastructure is also really minimal with 8 chargers, 22K charging power, which is not really fast charging at all. And for this system, they operate in 3 routes and they have around 146 round trips per day. This is kind of the case study characteristic. And here we can observe how was the behavior of the charging events during the day. Uh, the only thing I want to stress out is first, we don't need to necessarily charge all the vehicles 100% to have a operation daily. And also we guarantee that the fleet are never running below 20% during the day, the operation day, which is also important to keep the state of health of the battery in a good shape, so never breaching below 20%. And here we also have the power curve of the charging vents. And what is interesting to highlight here is that using our solutions, basically the vehicles are charged during the morning to, of course, to have energy to operate, but mainly when the energy is cheaper in the morning, and also when the energy is cheaper during the day, right, to reduce the operational costs. And another thing that's interesting, there's no charging events when the vehicles arrive in the depot, which kind of counterintuitive or is not really what operators do, because in this example, a specific example, the tariffs are much higher when the vehicles are arriving at the depot. So if an operator just plug in the vehicles when they are in the arriving, right, they will explode or have a larger cost, right? So this is not ideal in terms of reducing the operational costs for this example. The second one is with also a smaller fleet, but with bigger buses that they already have in Coimbra in Portugal. So 10 electric buses, BYD with 348 kilowatt hour. And the chargers are 10 with 100 kilowatt. And the trips are 420 round trips in 10 routes, different routes. And then I'm going to show you the results. So we also have simulated different scenarios. We could have the chance to go over different scenarios with this fleet, but I'm not going to stress right now with the details here. But what I want to present and highlight is the results that we got with this fleet. So first of all, in terms of charging power, it could reduce the charging power peak by 60% by controlling the charging vents. So later they are using all the vehicles and charging the vehicles at the same time, using the solution that we proposed, they could reduce in 60% this charging peak. The daily total operational cost, they reduce in 37%, which is quite a good and interesting aspect to have a cheaper operation. And we estimate that using this smart charging approach, they could increase the lifespan in 4 years on the batteries, right? Because they're gonna have a less cycles per day, right? On the energy level, which is also really interesting in terms of keeping the fleet operating for a longer time. And here is just an idea also in the planning analysis. So we also use the tools that we developed to play with different scenarios, sensitivity analysis, different fleet characteristics, charging power, also the fleet sizes and battery sizes. So we can also use the solution to do that. And as I said, we kind of build a platform on this, and later we can also go into detail on that if you're interested, and etc. You have a website where you can also get all the information. And just to finalize, I want to give you some future perspectives, which I believe is where the research should go, and I think could be interesting aspects to be looking at in the future. The first one is fleet replacement, but in the sense that we are going to have a lot of operators that are going to deal with mixed fleets, diesel and electric and hybrid at the same time. So um, having research to know better how to operate those mixed fleets, where we should put electric vehicles, where we should use diesel, how we're going to replace our diesel in a more optimal way. So having in 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 the first place this idea of this replacement or this transition that we're living right now, I think is a really interesting aspect to be assessed right now. Autonomous vehicles and autonomous buses, I believe that's also a really interesting aspect that we should looking in the future. Actually, today in our lab, we are really looking forward to autonomous vehicles. We have some collaborations with Luxembourg in Europe to develop some research on this, and maybe we can later talk about this. Second life batteries are an also really hot topic. So we can use those batteries of those any kind of EV, but even more electric buses for the second life operation to be kind of static storage systems. And life cycle assessments and for a last issue that I believe is really important to be looked at, because I mean the objective of all of this is to reduce emissions, right? But depending on the electric mix or how the batteries are manufactured or how the batteries are disposed of, we're not reducing much emissions, right? So always a life cycle assessment of the emissions of the entire chain is important, also to see how good is the solution and how we're impacting in terms of GHG emissions the environment, right? So this is also important. My last comment was always like to finish my talks is this is a picture of 2025. A really crowded city with a lot of traffic jams. Nobody's happy here, probably because they want to go home, but they can't because everything is really crowded. And this is a picture of 2050. It's the same picture, the same city, but the difference all those vehicles are electric, right? So what I want to highlight here are it's kind of uh, just something for a food of thought is that it's not only about transitioning to electric vehicles, but it's also rethinking the way we do our cities. It's about rethinking the way we come and go to make a transportation better for everybody, right? And also thinking on public transportation and also reshaping all those aspects to make our vehicles more sustainable, but also our transportation more sustainable. And then this is the last slide that I have. It's a quote by Gustavo Petro. It's the president of Colombia. He's also a guy that was always looking to sustainable transportation. He was responsible of the BRT in Bogota, which is the biggest BRT in the world. And he has this quote that I really liked: "An advanced city is not one where even the poor use cars, but rather one where even the rich use public transport." So yeah, maybe it is something interesting for us to think of. And again, thank you very much for your time. I think I did an overpass, but I'm not sure. But anyway, it was a pleasure to present. Thank you very much.
That was perfect.
Thank you.
Any questions from the audience? I have the mic that I'd like you to use.
Just one quick question. When you're looking at the different cities that had some of the
Or you are muted now. I started to listen to you, but then yeah.
Just getting a little echo.
Sorry, can you hear me now?
Yeah, I can hear you. There's a bit of echo, but it's fine.
So my question was, with regards to these buses, was there any findings regarding changing costs of maintenance compared to the diesel?
Yeah, thank you. I think you are listening to me well, right? So yes, in our platforms, we are not accessing exactly maintenance, but I have some insights from them about the maintenance. So in terms of Portugal, since because they are smaller, right? I think I'm hearing myself. Now it's better. Yeah. So since they have a smaller fleet, it was easier to them to do the maintenance. And from what I heard, what the operator from Portugal said, the maintenance was really cheaper than the diesel vehicles that they have. But there are some factors that we need to put on the table. First of all, the diesel buses they have there are really old, so this also increases on the maintenance. And at that point, it was, I think since the operation of for a smaller fleet, the vehicles were not much stressed in different conditions. So I think that this also played a role. And I'm saying this because I interviewed different public operators here in Canada and in the US, and sometimes the opinion is kind of mixed. Some operators say that the maintenance is cheaper for electric buses, but others they say the opposite, because sometimes you don't have the pieces to do some repairs. Sometimes you don't have even people that are knowledge to do the repair right now. So I would say that, just to wrap up everything, uh, in a perfect world, the operation of electric buses is cheaper. The maintenance of those electric buses is cheaper. But since we are facing a transition, that's not could be not the case for every operator, right? Um, Maybe I over answered you, but I don't know if it was good or not.
Thank you.
Yes.
Thinking of the battery degradation, I'm familiar a little bit with Jeff Don, Tony Bond, Canadian battery researchers. They've done a lot of work on degradation. Has your degradation assumptions correlated with theirs?
Mm. So unfortunately, I'm not really. I don't know exactly their work. Unfortunately, I would love to, and maybe though you can send me later their papers, and I would love to read. But all the methodology that we used wasn't invented by me, right? We used the methodology that's solid in different papers. So the ampere hour throughput model is something that has been used and proven for other scientists, not by me. And also the cycles and the degradation experiments that we did in the laboratory were also, we used protocols that were already published. So in this sense, I would say that what we did has scientific background. But I can't say that we are using the same approaches that the scientists that you mentioned, because unfortunately I'm not really aware, but I would love to know more about them. And I would love if you could send me some of their research, because probably it could improve what I did and also what I know. So I would be flattered to have the chance to read their work, definitely. But
Do
and
that
also if
afterwards
you
for you.
yeah, and also later if you, I mean, if you have a follow up on this, if you want to say also how they are doing the research, I would love to listen to.
And have you heard about the single crystal batteries, both for the iron and the lithium ion?
Um, yeah, I know the technology. I know what they're doing. I'm not. I mean, definitely, I'm not a chemistry. And this is beyond the scope of my research, which is more related to energy. And I know that there is being some interesting research over there. But yeah, I can't comment about the technology in detail because that's not my field. But I know that they are really developing some research on this, and also solid state batteries, right? So this is also something that's coming. Um, but yeah, I believe that battery is not going to be a problem, right? Energy storage system is not going to be a problem in the future. In terms of technology itself is not going to be a problem. The main problem that I see is more about the materials to manufacture those batteries, because they are really concentrated in some countries, right? So South America countries and China. So, and here I see the two problems. One is more about how we're going to get those resources, right? So there's kind of the same with petrol, right? So petrol is in some specific countries, but also there is the exploitation of the labor, right? I'm Brazilian, right? And I know how to extract those materials, how people are put in some degradation situations, right? So it's also has this human impact factor that we need to consider when also dealing with the materials to manufacture those batteries, right? But I believe that's also a discussion for it's another level of discussion, but yeah.
Thank you for your talk. I'm wondering whether you've used machine learning or artificial intelligence to try to solve your optimization problem. And if you could tell us
Yeah.
a little bit at that.
Yeah, thank you. That's a great question. I'm gonna love to answer to that. Yeah, so artificial intelligence is a really broad term for a lot of things, right? And definitely we use some materialistic approach to solve our models, um, which also falls into the idea of artificial intelligence, right? Because I mean, just being a little bit nerdy here, in terms of computational time to deal with those optimization models, they are kind of exponential computational problems. So to deal in those problems in tractable time, we need to have kind of a materialistic approach or a heuristic approach to solve the problems. So yes, we have developed our own materialistic approach to deal with larger fleets and to obtain suboptimal results, but still good results. And and also in terms of machine learning, what we are building right now, and I didn't present because it's still under development. It's a work that we are doing, a research that we're doing. We're creating a better degradation model that is trained using data sets. So we are also using machine learning to train the model to predict the degradation of the vehicles, the battery degradation using machine learning models. And we're doing something similar um, to the energy consumption of the vehicle. So we are considering different features because, as I said before, the energy consumption of an electric vehicle is impacted not only by the driving itself, but by external factors, right? The weather plays a role, the traffic conditions plays a role, and etc. So we are building a more comprehensive energy consumption model that considers all these factors. And to consider all of this, we are using a kind of a machine learning approach right now to have this prediction. But yeah, I didn't mention this in the presentation because it's a work that we are doing. We didn't publish nothing yet. So hopefully at the end of the year, we're gonna have something posted, and I would glad to share with you.
Hello. I have heard lots of people talk about how like the different buses in Canada have failed, the e-buses. How would I respond to that? Like, what's the truth?
Uh, Thank you for your question. Actually, I heard the same. Just a small parenthesis. I met Doug because what I was doing is a kind of a market validation, we call. So I participated in a program called Lab to Market. So basically, we get uh, the tools, the research that we developed on the laboratory, and I try to bring to the market. So I was doing this market research, and I was reaching a lot of experts in the field. Therefore, I talked with Doug. And besides Dog, I talk with a lot of operators, right? I talk here in Quebec with a lot of municipalities that are doing transition, Ontario, BC, all of Canada, and also some parts of the US, Chicago. And to be honest, it's kind of a mixed things, stations, let's say, and opinions. So some operators they had bad experience with electric buses, but I understand. And when I mean, talk with more and more, I could grasp some ideas why most of them failed. First, because it was a kind of pilot projects that weren't really well planned at the beginning, and also because the technology they used to the first pilots weren't really developed in the way that we are having now. So in terms of battery conditions, in terms of charge infrastructure, connection with the grid, all those challenges and problems and issues that I mentioned at the beginning. So uh, and also the biggest problem that I believe, and I learned it through this validation, market validation that I did, is that there's a big lack of understanding of the technology right now. So all those operators are learning how to deal with electric buses. So they didn't knew. So imagine when you don't know how to deal with something, the chance that you're going to fail is much higher than you're going to succeed, right? Because you're understanding how does it work, how you operate a electric bus, how you charge this bus, how you even drive, right? The bus, you don't even know how exactly how to drive the vehicle. So I would say that it's more about the fails is more about we are dealing with a transition, right? So it's also a technological aspect. The first generation of buses they weren't maybe uh, perfect, right? And now we're having vehicles that are much more robust and reliable in terms of driving range, in terms of battery conditions. And also there's the learning curve. So those operators were learning how to deal with those buses and those different systems. And once they learn, the operation is much better, right? We have the example of TTC, right? The Toronto Transit Commission, which I would say that's a case of success, right? And when I spoke with the manager there, he also said that to me. So at the beginning, it was really hard for us because we didn't know exactly how to operate. And we went phase by phase, expanding bit by bit our fleet, and then we understood better and really well how to deal with that. So my opinion is because we need to go step by step, right? And we can't electrify the fleets overnight. So if someone asks you if it should go electric or not, I would say yes, but be aware that it's going to be a learning curve, and at the beginning, things not going to work as you expect. So be patient, and everything's going to figure out at the end, right?
I have a question, please.
I understand this might be a bit outside your research scope,
Mhm.
but I just want to ask it regardless. Um, so during like production phase, you didn't talk too much about that during your presentation, but electric vehicles consume so much more energy and so much more materials during the production phase specifically. Wouldn't that offset any good you do when it comes to the usage phase?
Okay, there's a bit of echo in your response, so let me see if I understood everything. So you're basically asking about the life cycle of the vehicle, right? Um, and of course, when we look to the life cycle of the vehicle, the manufacturer is where we have the biggest emissions, right? So to manufacture the vehicle, to manufacture the battery, to extract all those materials, right? This is has a lot of impact. On the other hand, when you're operating the vehicles, the well to wheel, right, or better tank to wheel, we don't have any kind of emissions, right? It's emission free, but well to wheel, from where the energy come to the operation phase, depending on how clean is your energy or how not clean is your energy, you're going to have indirect emissions, right? So mostly of the vehicles, and I'm going to talk about the Quebec and also Europe perspectives. The EVs, they reduce emissions in the lifetime, even though the manufacturing phase is really uh, need a lot of resources, let's put like this. So normally during the lifetime, they reduce emissions because of the grid, because the grid's cleaner in Europe and also in Quebec and probably in BC too. So in that perspectives, it compensates to go electric because we're really reducing the emissions when you look to the all life cycle assessment of the fleet. But there are examples when or the operation is the same or emissions is the same or could be higher. For instance, in Poland, in Europe too, the grid is really dirt, right? And when we do the life LCA, the life cycle assessment of EVs in Poland, there are some type of vehicles that, although they are EVs, they emit during the life cycle, they have a larger emission of GHG than pure electric diesel ones, right? So, and I mentioned this as the next steps or future perspectives of research, considering and have an assessment of the entire life cycle of those vehicles is important to really understand how much we are phasing out of GHG or any kind of gas emissions in the atmosphere. Um, and just to mention another thing, the idea is also that we are passing by an energy transition and our energy sources are going to be even more clean, right? So we're going to have more solar, we're going to have more wind, hydro, and etc. So in this perspective of energy transition, definitely EVs are much better than diesel, right? So accounting for this transition, having even more cleaner energy, we definitely going to have um, using EVs compensates on the emissions. And last but not least, it's also important is the last thing that I mentioned, uh, having public transportation or transportation means that can bring a lot of people, in my opinion, is even better. So it is the best solution that we could have. Instead of only shifting all personal vehicles and EVs, what we should do is having transit systems that are reliable, that are suitable for everybody, and they are also clean. So I believe that this is the biggest turning point when we're dealing with emissions, right? I hope I answered your question, but thank you.
You did. Thank you very much.
Yeah, my pleasure.
Johannes,
Yes.
could you talk to us
a bit about the difference in the charging infrastructures in North America compared with Europe. Thinking about the ease of paying on initiating chargers when you're out traveling. That's the question. Thank you.
Okay. Again, I think there's some noise. So I believe the difference is about charging infrastructure. How is the today in Europe and here in North America, right? And I believe that there's a question more general, not for transit, right? It's more how is the charge infrastructure in Europe and compared to North America, Canada, and the US, I believe. So yeah, I'm gonna try to answer this. Definitely, the Europe's more advanced and in a fast pace when we are talking about the electrification process. And of course, this also regards not only adopting the vehicles itself, but in terms of charge infrastructure. So in Europe, it's really easy to find. I wouldn't say each corner, but in a lot of corners, you can find charge infrastructure or chargers, public chargers. Um, so they are really pushing this. Even in Portugal, I mean, if you compare Portugal with other countries in Europe that has much more money and are much bigger, Portugal is doing a lot of efforts on electrification. I mean, in my city, which is a small city, the city that I was living in Portugal, Coimbra, which is a small city, we could easily find charging points all over the city. Um, and yeah, I mean the work has been done and is really fast paced over there. Um, and they put a lot of resources to do to increase the number of charging points in Europe in general, because it's kind of the European Commission are investing a lot on that, right? So it's kind of a political um, it's political driven, right? So the policy on Europe's around this decarbonization, and one of the targets is to decarbonize transportation, right? So this is kind of a strategic point of Europe. When we come to just a parenthesis, but I feel that in Europe, for instance, what's something that's still missing is charging really fast charging infrastructure for roads, so highways. So we don't have this yet in Europe. So using our EV to go to different cities or different countries in Europe, I would say that's still not a good option. So we still need to rely on other types of transportation modes. And I believe there's also a problem in any part of the world. Maybe only in China we have good solutions to that. That being said, when we come to North America, I wouldn't, I can't say much because I don't know exactly all the landscape, but I can say what they have been done in Quebec and mostly in Montreal. So in Montreal, they're, I would say that in terms of Canada, they're really trying to push a little bit more on in terms of the the electrification process. And here in Montreal, we can see some charge infrastructure. I wouldn't say that it's the same level or quantity as we see in Europe. But for instance, in my building here, in the street, we have 5 or 6 charging points, which is interesting, right? So I would say that, I mean, definitely is a different pace. Um, and if we want to reach the speed and the pace that we're seeing in Europe, we need to have more investment, definitely. But again, it's kind of a political strategy in Europe to push to the electrification, and maybe it's not the same here. And probably you can speak better on this matter than myself because I know much more about the European perspective than here perspective. And just to finalize. I believe that the charging infrastructure and the adoption rates, they kind of shake hands, right? It's kind of a chicken egg problem. So should we buy or have larger EV fleets and then invest on the energy on the charge infrastructure, or should we invest in the charge infrastructure to make people more interested on adopting EVs? So I see that we have this chicken egg dilemma, but I would say that we should target both, right? It's about building the charging infrastructure to people and also bridging or making people more prone to adopt EVs by incentives, by reduction on the prices. Yeah, so I would say that both need to work together to increase the adoption rates of EVs in Canada and North America in general. And hopefully I answered your question.
Thank you. That's good. Any other questions from the room or online? Oh, we got another one. Just us.
Okay.
I hear people talking a lot about how there's all all these incentives and
Mhm.
money given to electrification and stuff. And they're complaining about that. And so I asked them to compare the incentives that gas and oil companies have
Mhm.
gotten and compared to that. So I've asked them to actually look at that and compare that. So hopefully that'll get them to think a bit more about that
Definitely.
it goes both ways.
Yeah, thank you for this comment. I agree with you. I don't have anything to to add. That I agree with you 100%. I mean, we're living a transition phase, right? And the lobby for diesel, for petrol, and etc. is really big, right? So people that are complaining about that is always going to exist, right? But I believe that we are in a point that there's no turning back, right? The technology is better, the maintenance is cheaper, and it's going to be even cheaper in the future. The possibilities that we have with electric vehicles, um, in terms of technology itself, right? Connection, IoT, um, I mean, everything's better, right? It's kind of really improving the transportation sector, is not going back. So, um, people that are kind of use it to one way to drive their vehicles or to think about transportation, yeah, they they're gonna see, I believe, in the future that they were kind of wrong. And yeah, there's no turning back, and definitely in a couple of years all the vehicles that we have are gonna be um electric. And I'm go a little bit ahead further. It's going to be autonomous. I really believe that we're going to reach maybe in 20 years or less uh, high levels of autonomy on transportation, and then we're going to see how our cities are going to be shaped by these new transportation systems. But I'm really hopeful for the future. And again, thank you very much for your comment.
That future, your 2050 picture would be different. It'd be a little more streamlined, a little more efficient, and you see a lot more smiles on the faces of the drivers.
I hope
Uh,
so. I really hope
question?
so.
So I think that's a wrap. It's a little bit before 11 o'clock your time, so
Yeah, good.
hopefully you're not too tired. Really
No, not at all.
appreciate your information and giving us some of your time. Thank you.
Again, so thank you very much for inviting me. Thank you for your questions. I mean, I'm not tired at all. I mean, those discussions and talking about these topics are always full for me. So again, thank you very much. If you want later to have some, I don't know, you want to have access to the publications that we're doing, the research that we're doing, I can send everything to Doug, and Doug maybe can distribute with everybody that were in the room or online. But I always available to answer emails, to connect, to have collaborations. And again, it was a pleasure to be here. Thank you very much.
Yeah, please share your information, share it with me, and I will put summaries and links to your papers in the newsletter.
Definitely, that sounds perfect. That's good.
And I'll get back to you in the next couple of days with information for Dr. Don and Toby Bond.
Please,
Okay.
please, I would love that.
Thank you.
Thank you. Thank you very much. Okay. Bye bye. See you later. Have a good evening for you. Thank you very much. It was a pleasure. Bye bye. Bye bye.